Hello and welcome to Unit 2, our first lesson. So in this lesson, we're going to be solving linear equations and inequalities. So this is review. What's nice about this is that it's going to be taking Algebra 1 topics and topics we saw in Unit 1 and combining them together. So a couple of definitions. So first one, equation. So it's two expressions that are equal to each other. So the difference between an equation and expression, we have an equal sign. Solutions are values that make the equation true. And inequality is a mathematical sentence that has less than, greater than, less than or equal to, greater than or equal to, or not equal to. And formulas is a mathematical equation where variables are used and expressed as a relationship between certain quantities. Now, you see formulas in math a lot. You also see them in science. And today we're actually going to be using some of them. So first, we're going to be looking at solving linear equations. So this is where we're going to be using kind of PEMDAS backwards, addition and subtraction, multiplication and division, to isolate the variable. Now, for our first problem, we have to realize that we have x's in different areas, so we're going to combine them together. I like to have a line through that equal sign. I would strongly recommend you do that because it keeps your work organized. So I'm going to add 8x to both sides. The reason I'm going to do this is because it's going to cancel that out. It's going to make it go to 0. And so 4 plus 8 is 12. So I get 12x minus 11 equals negative 16. Add 11 to both sides to get 12x equals negative 5. And then my last step is to divide both sides by 12 to get x equals negative 5 twelfths. We should ask ourselves, can we simplify? We cannot. And if you really wanted to and you had time, you could plug it back in. Plug in for x to check your answer. If you wanted to, you don't have to, but let's say you had time and you had a couple problems that you weren't confident about, you could plug in that value into x into your calculator to confirm that it is true. It is true. So let's go on to our next problem. So for this problem, we've got fractions. Now, there's two ways that you can deal with this. If you wanted to, you can distribute the fraction. Okay? Now, I don't like doing this because what ends up happening is you have more fractions sometimes, which can cause a bigger issue. So instead, what I suggest is clear fractions. And so how we clear fractions is we find, first step, find a LCD. And so what that is, it's a common multiple of your denominators. Well, we're lucky for this problem that they are the same denominators. So our LCD in this problem is 3. And so what we do next is you multiply both sides by the LCD. By LCD. Okay, so what that means is, again, line through that equal sign. We're going to multiply both sides by 3. What we do to one side, we have to do the other. Now, what we're going to do is we're going to distribute it into each term. Now, I'm not going to distribute it into the parentheses because I've already dealt with the parentheses by multiplying it to that fraction. And so 3 times 1, because what we do is we multiply across, we get 3 over 3. And then I'm just going to bring everything down. And then 3 times 1 is 3. 1 times 3 is also 3 to get 6 minus x. And then on the other side, negative 4 times 3 is negative 12. Now, you can skip this step if you want to do it in your head. So like the 3's would cancel, giving us 1 times 2x minus 57. Same over here, the 3's cancel, giving us just that 6 minus x times 1. You can also skip this step because 1 times anything is itself, but if you need it, you're more than welcome to have these steps. for your problems, okay? So we get to 2x minus 57 plus 6x minus x. I am going to combine my like terms. So remember, like terms are the same variable and same exponent. So I'm left with x, and then I'm going to combine my other like terms, which are these. To negative 57 plus 6 is negative 51 equals negative 12. My last step is just to add 51 to both sides to get x equals 39. And there you go. So that is how to clear fractions. Now again, if you wanted to, you could distribute fractions. You don't have to. Sometimes they give you nice numbers. In this case, half of them would. If you want, you can ask me more about that in class. And our last problem that we're going to look at that we can have is decimals. So decimals work the same way as normal numbers. We just are going to have decimals. So I get 0.6x plus 3.4x minus, you're lucky because I'm going to give you the answer, negative 4.08. Combining like terms will give us 4x minus 4.08. Again, we want to make sure we are showing all of those steps. Now I'm going to start to isolate my x, so I'm going to add 4.0x to both sides, which will give us 4x equals 10.88. And then my last step is to divide both sides by 4, giving us x equals 2.72. Now, if you actually followed along and plugged that into your calculator, that is exact. Okay? We would not need to round or anything because it's a terminating decimal. Okay. So that is solving linear equations. What we're going to do on the next page is solve literal equations, everyone's favorite thing. We've kind of talked about it before. What it is isolating a variable. So it's taking the steps that we saw on the previous page, and instead of having numbers, we're going to have variables. So we are going to be isolating a specific variable. I personally like to put a highlighter, like I like to highlight the variable we have to isolate so I don't lose track of it. So I'm going to isolate b. So I'm going to subtract 2a from both sides, giving us p minus 2a equals 2b. From here, I'm going to divide both sides by 2. Now, technically, we can have p minus 2a all over 2 equals b. That is one form. But because we are Algebra 2 students, we can take this one step further and simplify those fractions to get 1/2 p minus, well, 2 over 2 is 1, so minus a equals b. That would be another way that we can write it, okay? So there is our first. That is how that's literal equations, solving for a specific variable. Our next one is solving for h. So here's h. I have a fraction, so what I'm going to do first is I'm going to clear out that fraction, meaning I'm going to multiply both sides by 2. So I get 2a equals, well, these 2's canceled out, and that's because that whole term is grouped together with that multiplication, and 1 times anything is itself, so I'm going to have h times a plus b. Now, again, I'm trying to isolate h, and h is being multiplied by a plus b. So if I keep that group together, that a plus b, what I do to one side, I do to the other, they will cancel out, leaving me with my variable. And so we get 2a over a plus b. And unlike the problem above where we could separate it, we can't because the denominator is 2 terms connected together. Voila! Okay, we are doing good so far. Let's go on to the next one. So we're going to be solving for w. Hopefully you know what this equation is. We are going to divide both sides by LH. So you might be wondering, why do I have this fancy L? It's because when we write with pencil, it's difficult to tell if it's an L or a 1. And so that's why we use that fancy L. And so the L's cancel out and the H cancel out, leaving us with W. And then I just get V over length times height. You might have guessed it or looked at the problem below, but this is our volume of a box. Woo! And so our next problem, well, hopefully you're feeling good with literal equations, because the purpose of a literal equation is you might not always be given specific information. You might be given information on both sides of the equation. So being able to isolate a variable can be very helpful. And so I'm going to prove it kind of to you. We are given the volume of a box is 2,160 centimeters squared. Its length is 15 centimeters and its height is 8 centimeters. We are asked to find the width. Well, in our previous problem, we found the formula for width because that formula above that we were given is the formula for a box. And so what we can do is we can plug in 2,160 in for the volume. Then the length is 15, so 15, times the height, which is 8. And so when I plug this into my calculator, I'm going to do 2,160 divided by, I'm going to group parentheses, 15 times 8. Those parentheses help the calculator know that 15 and 8 are in the denominator to get, whoopsies. I did not actually solve this. I'm going to plug this really quickly in. Divided by parenthesis 15 times 8, we get 18. And because this is a word problem, we would want to have that units. So 18 centimeters is the height. Oopsies, not height. Whoa! The width. La la. Okay. So that is just kind of like a reason why we would want to isolate a specific variable, is we would have certain pieces. Okay, so done with section 2, going to section 3. We're going to be writing an equation and solving. So this is taking kind of like written word, turning it into an equation, and then based on that equation, let's solve for our variable. So best way to do this is to read it out loud first. Well, read it either out loud or in your head. You do need to remember that is means equals. This means equals. So, for example, 5 increased by 4 times a number is, so that's equals 29. So that's our first piece. So we were asked to find the number. So we got our right side. Let's look at the other side. So we have 5 increased, so we're adding, by 4 times a number. Well, we don't know what that number is, so let's use the variable x. And so bringing all of that together, we would get 5 plus 4x equals 29. And now we can solve, so subtracting 5 from both sides, we get 4x equals 24. And then finish the problem, we're going to divide both sides by 4 to get x equals 6. So the number is 6. So we're just taking a sentence and turning it into an equation. So let's look at our next one. So we have 20 is less than a number. 20 less than twice a number equals the number less 4. It is the we are asked to find the number. So let's go through this. 20 less than twice a number equals, so in this place it actually has the word equals, that number less 4, so minus 4. And that is how we set up our equation. So let's solve. I'm going to subtract x from both sides to get 20 minus 3x equals negative 4. I'm going to subtract 20 from both sides to get negative 3x equals negative 24. Dividing both sides by negative 3, double negative will become a positive. So 8 is our number. Okay, let's go to the next page. For this problem, so it says the quotient of a number and 3 less 2 is 7 less than twice the number. We're asked to find the number. So quotient means dividing. So the quotient of a number and 3, so a number, and 3, less 2, so we're subtracting 2. Notice how that word is shows up, so this is where we're going to bring in that equal sign. 7 less than twice the number. So if we write this, 7 less than 2 times the number, okay? However, because it's saying is 7 less than 2 times the number, we're not subtracting twice it. We are taking the number and multiplying it by 2 and then subtracting 7. So this one you have to flip around. So be careful. Okay, so let's solve this. I am going to combine like terms first, so I'm going to add 2 to both sides. Just so I can combine as many like terms as possible before dealing with that fraction. So we want to clear out that fraction, so our LCD, since there's only one fraction, our LCD is 3. So we're going to multiply both sides by 3. Well, these 3's cancel out, giving us x equals. Well, we can distribute that 3 in because there's no given parentheses. So we get 6x minus 15. I need to work on giving you more space. Whoopsies. Okay. Going up here, I'm going to subtract 6x from both sides, which will give us negative 5x equals negative 15. And finishing the problem by dividing both sides by negative 5, we get x equals 3. So that is writing an equation based on a written problem and solving. Okay, so that's topic 3. Our last topic is linear inequalities. We saw this in Unit 1, where not necessarily solving inequalities, but inequalities of like graphing them on a number line and writing the interval. So we're going to take that topic, and what we're going to do is we're at the beginning of that type of problem is we are going to have to solve for x. So it's very similar to what we did at the very beginning of this video. The only thing that's going to be different is this right here. If we multiply or divide by a negative, we have to flip the inequality. So, for this problem, very similar, we want to move all of our x's together. So I'm going to subtract 3x from both sides, giving us negative x plus 5 is greater than negative 1. I'm then going to subtract 6 from both sides to get negative x is greater than negative, wow, caught my mistake, I know. Whew. Subtracting 5, so I get negative 6. And then I'm going to divide both sides by negative 1. Now, because of this right here, we need to flip the inequality. What that means is we are now going to be x is less than 6. So there is our inequality. We are now going to graph that number line. So here's 6 with an open circle, and x is less than it. So we're going to go to the left. And so our interval, this should be review, is going to be parenthesis negative infinity to 6 with a parenthesis. Remember, those parentheses and open circles are coming from that inequality that we have. Okay, let's do our next 2 problems. We're almost done. Here we go. So, next one, I'm going to add 6 to both sides, giving us a over 4 is less than or equal to 8. I'm now going to multiply by 4. Now, I have not multiplied or divided by a negative, so my inequality stays the same. So I get a is less than or equal to 32. So when I graph this, here's 32. I have a closed circle on 32, and a is less than, which means we go to the left. And so our interval then is negative infinity to 32 with the bracket. Again, the reason for that bracket is because we have a closed circle based on that inequality. Okay, last problem we're gonna do. Here we go. Okay, so I'm gonna distribute that 7 in. So I get 20 minus 3n is less than 7n minus 35. Now, I know some of you might subtract 7n, But for a moment, I want you to add 3n to both sides. Kind of have to write small in here, just be careful. So we get less than 10n minus 35. Then I'm going to add 35 to both sides, which will give us 55 is less than 10n. And now my last step is to divide both sides by 10. I'm just going to bring it over here. So what we get is 55 over 10 is less than n. Well, they both have 5 in common, so when I divide the top and bottom by 5, I get 11 over 2 is less than n. Now be careful. I always like to tell people that the variable is going to switch. So instead of using the inequality for telling you which way to graph, make sure, okay, here's 11 halves. We have an open circle, n is greater than, so we're going to go to the right. Now, if you want, you can flip it so the variable is on the other side. You just need to make sure that you flip every single piece. So you're doing the mirror of it. And so, n is greater than 11 halves. What that means is when our interval is going to be parenthesis 11 halves to infinity with a parenthesis. Okay, so that was solving inequalities, kind of bringing everything together we've seen so far. What you're going to do is do a quick summary, put questions or things to remember. I would put flip the inequality if you multiply or divide by negative. Closed circle is brackets, open circle is parentheses, and stuff like that. What you're going to do now is on this page, you're going to do the practice. You should have all the skills to do it. I believe in you. If you have questions, come to class with them. Thank you.